All right, so we're going to start with the 7-1 warm-up, and then we're going to go through the 7-2 notes. So in 7-1, we talked about the Pythagorean Theorem, which is what?
A squared plus B squared equals C squared.
Good. A squared plus B squared equals C squared. And what's special about C? Good. Has to be the hypotenuse. So the other two are interchangeable, but C has to be the hypotenuse. So in this example, which one is the one that's by itself? The x. So I'd get 15 squared plus 36 squared equals x squared. 15 times 15 is 225. 36 times 36. 200, and what is it? 96, thank you. Save me from doing the work. All right, then 11, 12, 15. Squared, and x would equal the square root of 1521, which we have to see if can be reduced. So it's obviously not even, which means it's not divisible by 2. If I add up the digits, 1 plus 5 is 6, plus 2 is 8, plus 1 is 9. Is 9 divisible by 3? Yeah, so I can start there. So this would be 3, and then 5, 0, 7. And not divisible by 2, but is it divisible by 3? 3 and 1, 69. And 169 is 13 times 13. So there's 2 3s, which means 1 3 comes to the outside, and there's 2 13s, which means 1 13 comes to the outside. Multiply them together at 39, and there was nothing left underneath. So x is just 39. Alexis.
When it's like that, is the whole number to use squared or no?
When it's that, was there a square root over it, you mean?
Yeah.
No, if I've brought it to the outside of the square root, then I lose that square root. So because there's 2 3s, I brought it to the outside of the root. Technically, there would be a square root here, but there's nothing left underneath it. So you don't need it. You just keep it as the 39 on the outside. All right, number 2 says find the area of an isosceles triangle. So area formula for a triangle is what?
1/2 times the height.
Good, 1/2 base and height. So I know the base is 48, but what I need is the height. What's true about the isosceles triangles? Why can I do this?
Because the sides are equal.
Good, so the H is going to hit that 48 where? Right in the middle. So that means that these are 2 triangles. This would be 24 and this would be 24. So then H squared plus 24 squared would equal 51 squared. 24 squared is 576. 51 squared. Subtract it. Thank you, 20, 30, 35? Yeah, 25. Okay, and then I would square root it. Okay, this time I could start with something a little bit bigger, like I know 25 goes into it, right? Or what'd you start with? Not 2. Does 3 go into it?
5.
You could do 5. 5 is easy and obvious, right? So 5 would be 405, which again I can do 5. 81, 9, and 9. I already have doubles, but if I want to keep going, 9 would be 3 and 3, and 3 and 3. So this time I have a pair of 5s, it's going to go to the outside. A pair of 3s, it's going to go to the outside. Another pair of 3s. So I've got 9 times 5 or 45, and nothing left underneath. So that's the height of the triangle. So 1/2 base, which is 48. Times the height, which is 45. Or 24 times 45. (1,080), and this unit is centimeters squared. Raise your hand if you got it. Okay, good. Questions on it? Mm-hmm. No, no calculator on the quiz. The power of your brain. I do expect you to multiply 2-digit numbers by 2-digit numbers. I know I'm evil. Sorry. A little tricky to get your calculators. All right, number 3, find the unknown side lengths and then write your answer in simplest radical form. So where can I start? The one on the right has 2 unknowns, but the one on the left has what? One unknown, and if this is a right angle, this is a right angle. Is there a triple? 10, 6? There is. You could have saved yourself some times. It's 6, 8, 10. Yeah, it's on the list. Okay, it's good practice. Okay, and then the other side would be 8 squared plus 12 squared equals x squared, 64, 144, 8, 208, square root of 208, which is not going to be a perfect square, but it's 2, and 104, 2 and 52, 2 and 26, 2 and 13. So I've got one pair of 2s, the 2's going to the outside. Second pair of 2s, another 2 going to the outside, and that 13 all by itself is going to stay underneath. So this would be 4 root 13. Okay. On the quiz, there's 8. Yeah. So it's this section we're going to do today, and then you've got one more that you're going to take notes on tomorrow. No, Wednesday. No, Thursday.
Wait, what's the one on tomorrow?
Because you're going to do just a section 1 and 2 review tomorrow, and then the next section, and then a quiz review on Friday. So 7.2 is called the converse of the Pythagorean Theorem. So we know from first semester that a converse is what? Flip the order, right? So if it said if this, then that. So it said if a triangle is a right triangle, then a squared plus b squared equals c squared. What do you think the converse is? See, you could have taught today's lesson. If a squared plus b squared equals c squared, then it's a right triangle. So that's 1/3 of what you're today, but that's the first one. The converse of the Pythagorean theorem. If the square of the longest side of a triangle is equal to the sum of the squares of the other two sides, then the triangle is a right triangle. Or if a squared plus b squared equals c squared, then the triangle is a right triangle. Okay, more triples. So the one that I had added onto that list yesterday is there, but also these additional ones. So 8, 15, 17, it's kind of a tricky one just because that's 17. That's why I gave it to the other day. 10, 24, 26. 9, 12, 15, 12, 16, 20, 15, 25, 15, 20, 25. So I would say really the only one on this list that you couldn't figure out without breaking it down into your factor trees, the first one. Like 17 squared doesn't break down into anything other than 17 squared. But I can get to 26 by breaking it down, with a factor tree. I can get to the 15, same thing. The only one on the top is the one that's kind of hard. But the rest of them are really just to help you. I'm not going to say, give me a list of all the triples, and you have to list them. That's not what it is. It's there to help you when you're doing the work. That's all.
Yeah, so is it more of having to memorize the triples, or is it a way to figure it out?
No, memorizing triples is just the way to help you out to make it faster. And a lot of standardized tests will put triples on there because they save you time. But you can do it without it. All right, so theorem 7.4, okay, which again has no name, and the number doesn't have any significance. The fourth theorem in chapter 7. It says if the square of the longest side of the triangle is less than the sum of the squares of the other two sides, then the triangle is an acute triangle. So if c squared is less than a squared plus b squared, then the triangle is acute. So equal is right, less than is acute. What do you think is going to be greater than? You guys are so smart. See, you could have led today. I didn't even have to be here. Okay, and that number should have changed. It should now be 7.5. The square of the longest side of the triangle is greater than the sum of the squares of the other two sides, then the triangle is an obtuse triangle. So now if c squared is greater than a squared plus b squared, then the triangle is obtuse. So I think it makes sense, hopefully it's easy to remember if you put the c first. So if the c comes first and it's less than, think less than should be acute. Okay, if the c is greater than, then it's obtuse. And if the c is equal to, then it's right. So those are the 3 that you'll be trying out. It'll say, can it form a triangle? If it can, what kind of triangle? So that's it. Now you got to figure it out. So the first thing that says the sides of the triangle have the lengths given is the triangle acute, right, or obtuse. So here comes back. And so you trade proofs for having to multiply a bunch of numbers together. Okay, there's your trade-off. Sorry, deal with it. All right, so A says 20, 21, and 29. So hopefully these are easy to figure out which would be the C, because the C would be what? The largest side, which is 29. Okay, so you're basically saying what relationship does 29 squared have to 20 squared plus 21 squared? And then you got to do the work. So 29 times 29, 81, 18, 16, 26. 841. 20 squared is 400. 21 times 21 is 441. So 841 has what relationship to 841? It's equal, and if it's equal, this is a right triangle. God bless you. All right, so B is 30 squared has what relationship to 20 squared plus 21 squared? 30 squared is 900, 20 squared is 400, 21 squared we already found out was 441. So what relationship does 900 have to 841? It's greater than this, which means obtuse. Okay, C, 8, 5, and 6. So 64 has what relationship to 25 plus 36? What relationship does 64 have to 61? It's greater than it, so this would be obtuse. Okay, so then they get a little bit trickier. You will see like decimals and stuff, but you also see something like D where you've got a square root. So the harder part about these is trying to figure out the order that they go in. So certainly I know that 8 is bigger than 4, right? But 4 square root 3 might be close to that third number. Let's say it was 4, 5, and 4 root 3, and you were trying to figure out which one it was. You want to approximate. So like square root 3 is closest to what perfect square? What's a perfect square that square root 3 is near? 4, right? 4 is a perfect square. Yes? 4 is a perfect square. Yeah, 2 squared is 4. Yeah, yeah, yeah. We're good on that part? Yeah? Okay. And root 3 is close to root 4. Yes? Yeah? Okay. Is it bigger or smaller than root 4? Smaller. So what is root 4? 2. So root 3 is a little bit less than 2. You follow me? So we're approximating what root 3 is. So let's just say I give a root 3 like a 1.8, something like that, right? If I multiply that by 4, then I can approximate that it's about 7.2. So if that third number was 5, I would know the longest of these 3 is really 4 root 3. Does that make sense? Because the longest has to go where the C is. Does that make sense? Yes? Okay. So this one hopefully was a little bit more obvious because I've got that 8. 8 is definitely bigger. So the 8's going to go first, then 4, God bless you, then 4 root 3. So when I square 8, I get 64. What's the square of 4? 16. And then this is 4 root 3 times 4 root 3, or 4 times 4, which is 16, times root 3, which is 3. So this becomes 48. So this is the way to check to make sure that you put it in the right order. Once you've squared it, the largest number should be on the left, okay, which it is. So 64 has what relationship to 64? They're equal, which makes this a right triangle. Alexis. So you do 4 times 4, which gives you the 16, and then root 3 times root 3, which is just 3. So when you square a square root, you get rid of the root. Because it would end up being root 9, right? And root 9 is 3, so you can just cut straight to it. Alejandro. No, if there was a plus sign in between the 4 and the root 3, I'd have to FOIL it. But because it's straight multiplication, I can just multiply it. Good question, though. Okay, so then the last one is E. So I've got 1, I've got 3, and I've got root 10. So let's try this again. Root 10 is closest to what perfect square?
10. Oh, that was
root 9, right? And it's a little bit bigger than root 9. The square root of 9 would be 3, so it's a little bit bigger than 3. So even say it's 3.1, I know it's going to be bigger than 3. You with me? So that root 10 is going to be on the left, because that's my C. So the square root of 10 squared has what relationship to 1 squared plus 3 squared? Square root of 10 squared is what? 10. 1 plus 9, 10, has what relationship to 10? It's equal, so this is a right triangle. So again, if you're not the best at approximating, once you've squared them, you can double check yourself. Once I've squared them and got rid of the radical, the largest number should be on the left. That's how you know you did it right.
Wait, so multiply the square root of 10 by the square root of 10. How'd you get 10 again?
It technically is square root of 100, right? Because I do 10 times 10, which backtracks to 10. But you don't have to do that work. Anytime you square a square root, it's whatever the number is underneath.
Oh.
So the square of the square root of 25 is 25. Doesn't matter what it is. They're like the inverse of each other. They're canceling each other out.
If there was like a 2 next to the 10, you would, and it came out to be 4.
Yep.
You would just add it to the 10?
So if I was squaring it, is that what you're saying? Like if it was this,
Yeah.
and I squared it, this would be 4 times 10, which is 40.
Oh.
So it's 2 times 2, and then root 10 times root 10. 2 times 2 is 4. Root 10 times root 10 is 10, but it's multiplication. All this stuff we're not adding yet. Like we're not doing any of that stuff. We're all multiplication, okay? Any other questions on that? Okay, so this just puts the three things together. 7.2, which says that if they're equal, it's a right triangle. 7.3, which says if it's less than, it's acute. And 7.4, so that actually the 3 was the one that was wrong. That says that if it's greater than it's obtuse. So that's all you need to know from this section. So again, today I'm going to open up your homework right now. You've got 12 minutes to start it. But tomorrow you'll get like just an extra practice worksheet. It's not that bad on 7.1, 7.2. And then Thursday you're going to take notes on 7.3. And Friday you're going to have a quiz review for 7.1, 7.2, 7.3. Okay. Okay, so this is from the homework. It says solve for x if the lengths of the two legs of a right triangle are 2x and 2x plus 4, and the length of the hypotenuse is 4x minus 4. So if you want to give yourself a visual, you can. I could say this is 2x, this is 2x plus 4, and this is 4x minus 4. But you don't need it because all it's telling you is that this is my C. So if a squared would be 2x squared plus b squared would be 2x plus 4 squared would equal 4x minus 4 squared. And basically what I've got to do here is the first one I can just multiply times itself. So 2 times 2 is 4, x times x is x squared. But these other two I have to FOIL out. So 2x plus 4, God bless you, times 2x plus 4. First would be 4x squared. Outer would be 8x. Inner, 8x. Last, 16. And then the one all the way on the right, I would have to FOIL as well. So 4x minus 4 times 4x minus 4. First is 16x squared minus 16x minus 16x plus 16. And then I would go through and combine my like terms. So I've got 4x squared plus 4x squared, which is 8x squared. 8x plus 8x is 16x plus 16 equals, on the right-hand side, 16x squared. There's 2 negative 16x, so that'd be negative 32x plus 16. You with me so far? Yeah? Now I got to combine my like terms. So everything that's squared, I want to one side. So I'm going to subtract the 8x squared. Get 16x plus 16 equals 8x squared minus 32x plus 16. And then I would subtract the 16x. And I get 16 equals 8x squared minus 48x plus 16. As soon as you see that there's going to be an x squared and an x, I know I'm going to eventually have to factor this, so that's why I'm getting everything to one side. And then that cancels out. So then from here, what can I factor out of both those terms? 8x, and this would be x minus 6. And then if you remember your factoring properties, I can set each of those equal to 0, divide that by 8, and x equals 0, add the 6, and x equals 6. So there's two answers for the algebraic part of it. But what happens if I plug the 0 back in? Like, what do I get if I multiply 2 times x? 0. Can I have a side length of 0? No. So it rules out the 0 and just keeps the 6. So second good news of the day. There's nothing like that on your quiz, but it's definitely good algebra practice. Okay. We're going to do, we're actually going to finish your book this, in the fourth quarter and do a little bit more of algebra review at the end to kind of prep you for Algebra 2 honors. That's the good news. So the factoring and all that good stuff will come back. Most of you like it better than the one thing that we didn't cover. We've covered it before. It'll ask, is it possible to form a triangle? Do you remember the rule? What does every pair of sides have to be? Bigger than the third. So if you add two small ones together and they're not bigger than the third, then no triangle exists. So you don't even classify it.